Welcome to video 4.4c, even more proofs with the equidistant theorem. So this is example 3, and I'll go over this one in great detail, the planning stage and everything. This one's a little bit more involved. All right, so here's example 3. So given F is the midpoint of BC, let's just start marking things up like we would. DB is congruent to EC. DB is perpendicular to DF. I'm going to mark my right angle inside that triangle. I just have an inkling that that triangle is what I care about. You could do it there as well. EC is perpendicular to EF. Likewise, I'm going to mark it in there. Prove that AF is perpendicular to BC. So as far as my question mark, I want to prove that this is the perpendicular bisector of this thing down here. Okay, so it's important you know who's perpendicular bisector of who. Okay, all right, so that's the markup stage. Again, whenever we see perpendicular, they just said perpendicular, not perpendicular bisector. But if I do get the perpendicular bisector, well then of course I got perpendicular. Okay, so whenever I see perpendicular, I'm looking for two equidistant points, okay, on the thing that's doing the bisecting. So I would like this point to be equidistant, and I would like this point to be equidistant to that segment down below. Okay? Oh, I've already got one of them right here with the midpoint. So now it breaks down to, really, can I get this side to be congruent to that side? So that's how my brain is doing my planning. Okay? So that's the crux of the proof. Oh, this triangle and this triangle, if I can get them congruent, which I think I can, I've got a right angle, I've got a hypotenuse, I've got a leg, by HLR, I can get those triangles congruent, then I can get those parts congruent. Oh, and if I got this angle congruent to that angle, then I would get this side and this side congruent, and then excuse me, then I would have my two equidistant points, proof over. So that's the game plan. If you want to pause the video right now and try it, I suggest you do that. I'll show you how I'm going to write it out. So again, what I'm going to do is try to go in HLR order and establish those two equidistant points. Okay, so first I'll get the triangles. So the hypoteni are here. Just so you know, that's a hypotenuse, leg, leg, right angle, right angle. So I'll start with this. F, midpoint, BC, given. From that, I'm going to get the congruences. BF, congruent to CF. If midpoint, then two congruent segments. So that is also one of my equidistant points, and also it is the hypotenuse. So that's got a double importance, that step right there. Okay, now I'm going to go for the legs. They gave me that. DB is congruent to EC, given. And then that whole if perp then right stuff, we've been doing that forever. So I'll put down those givens. So DB is perp to DF, EC is perp to EF, given. Then I'm going to establish the right angles. So angle, I'll just go BDF, and angle CEF are right angles. If perp, then right angle. Now only for HLR, I do not need to establish those right angles congruent. I just need to know that they exist. Okay, if you want to go ahead and establish them congruent, go for it. So I've got HLR, so now I got the triangles congruent. So triangle, I could just use that same setup. BDF is congruent to triangle CEF by HLR. Then once I get the triangles, I can get the parts. So angle, I could go angle B is congruent to angle C. I could just use one letter because I don't have any ambiguity there. CPCTC. Then I do have to get the sides. So I could say side AB is congruent to side AC. And that's looking at that big triangle being isosceles. If these angles are congruent, then the big sides of the isosceles triangle are congruent. Okay, so for part 8, that was if angles, then sides. And I get credit for another equidistant point. I'd like to put them there. Now I'm ready to go. AF is perpendicular to BC. If kite thing, then perpendicular. They don't care about perpendicular bisector, but I'll just throw it in to be consistent. And there you have it, how to do a slightly more involved proof with the equidistant theorem. Got one more to go.